Okay, continue. Okay, for criteria for effective network. Okay, the first criteria is performance, second is reliability, third is security, fourth is robustness, and fifth is applications. Okay, what is performance? Okay, performance depends on number of users, types of transmission medium, hardware, and software. Okay, we touch on the first performance criteria, which is the number of users. Okay, let's say you are connecting to a access point using the Wi-Fi. Okay, then you try to stream the movie from YouTube. Okay, you can see that if you are the only one that streaming the YouTube, you can see the performance and the speed of movie is very good and clear. Okay, but if after that, okay, all of your friends came to the class nearby you, and maybe 20 of them simultaneously streaming the YouTube. Okay, you can see the YouTube is jerking, or normally we call as lag, right? You can see the lag. Okay, so you can say that the when you increase the number of users, the performance of network can be dropped. Okay, by referring to YouTube, you can see it is lag lah. Okay, second criteria is the reliability, frequency of failure, recovery time of a network after failure, and contingency plan on catastrophe. Right? Okay, you can imagine when you connect to the Wi-Fi. Okay, sometimes you can see there is no coverage of Wi-Fi, or less number of bar, and suddenly no bar at all. Okay, so you can say that your network or your Wi-Fi is currently failed. Okay, and maybe in a few seconds later, okay, when you refresh the Wi-Fi connection, okay, you can see there is Wi-Fi again. So the time between the failure and Wi-Fi okay again, we call as recovery time after failure. Okay. And finally, contingency plan of catastrophe. For instance, okay, sometimes you are connecting to Wi-Fi in FTMK. Okay, you can see that on the ceiling, you can see some shape like a UFO. Okay, right? You can see on top of the ceiling, right? Okay, so that is what we call as AP. Okay, so if you have only one AP, in case the AP is a problem or fail, then you don't have the internet connection through Wi-Fi anymore, right? Okay, somehow at the FTMK corridor, you can see that we have several UFO shapes on the ceiling, right? So the several or two or three UFO shape device we call as access point. Okay, if you have more than one, this is what we call as contingency plan of catastrophe. Means that if one of the AP fail, okay, you can still connect to Wi-Fi through the other AP. So this is what we call as plan B or contingency plan. Excuse me. Okay, the third criteria is security, okay, unauthorized access and viruses, right? So normally when you want to connect to Wi-Fi, okay, you are required to enter your user ID and password, right? So means that, okay, for those that unauthorized, they are not able to connect to the Wi-Fi. So this is what we call as the security measures lah. Okay, and the other thing is for to combat or to fight against viruses, so there will be an antivirus lah, okay, in the network infrastructure. Okay, the fourth one is the robustness. Okay, robustness, the factors affected by a noise and environment. Okay, okay, means what a noise means that if you put an access point, okay, nearby several electrical devices, okay, all the electrical devices have what normally we call as radiation. Okay, normally you think about radiation. So in other words, radiation is what we call as a noise. Every device, okay, will radiate the noise. So if you put the AP nearby the electrical devices, so electrical devices, so you can see the performance of the network will be lowered or will be affected. Okay, okay, and the final criteria of effective network is applications, right? Okay, marketing and sales, okay, financial services, manufacturing, okay, CAD/CAM, all using different types of application or software. Okay, so it depends. So for a high bandwidth environment, okay, such as video streaming and so on, okay, they need a powerful network, okay, an AP with a higher bandwidth rather than okay, office work. Okay, when you are working in an office, you normally use normal software such as PDF, Microsoft Word. Still, you want to access to the network, right? Using Wi-Fi. Okay, okay. In that type of application, it requires lower grade or lower bandwidth network. Okay, excuse me. Okay, the 3.3 is a network topologist. What is topology? Topology is the physical or logical arrangement of links in a network. Okay, let me go with you here. Right. Okay, so basically topology can be subdivided into four types of the topology. The first one is the mesh. Second one is a star. Third one is a ring. And fourth one is bus. Okay, okay. So to make your life easier, you can just remember not only by memorizing the details description, but you can make it as a common sense formula. Okay, for instance, we go on to star first. Okay, what is star in English? Star means the shape of star, right? Star. You can see here we have five ends here, five sharp ends. Okay, so in other words, this is something like a star. Okay, you can have a star here. Okay, something like star shape. Okay, in which if you see a star, okay, every edge will connect to the middle part. Okay, will connect to the middle part and then only connect to the other node. Okay, erase, let me erase first. Okay, okay, you see that just now I draw the shape of star. Okay, so in other words, in the star topology, okay, point again. Okay, in the star topology, you can see that okay, this is node number 1, node number 2, node number 3, and node number 4, like I have discussed in the earlier section, right? Okay, node is a PC lah. Example of node is PC or your smartphone. Okay, so in star topology, okay, for node number 1 or PC number 1, in order to send messages to uh, PC number 2, they must pass through the middleman or middle interconnecting device we call as hub or switches. Then only you can send the message or email from PC1 to PC2. So this is the idea of star, in which you can memorize by using the shape of star. Okay, they must pass through the middle interconnecting device. So what is the limitation of star topology? Okay, so let's say if the check the in color. Okay, let's say the hub faulty or fail. Okay, can the network connection took place? No, right? Because in order to send the data from one node to another, they must pass through the middleman or the hub. So if the hub fail, they are not able to send the data. So this is the limitation of star topology. Okay. Okay. Sorry. For ring topology, we can imagine the shape of a ring. So normally we draw a circle ring, right? Okay. You have gold here or diamond here, right? Okay. So this is something like a ring lah. Okay, even though it doesn't really shape like a circle. Okay, so this is the idea of a ring. Okay, so all the connection is in the form of circular connection. Okay, so let me clear this one first. Okay, point again. Okay, so for node number 1, node number 2, okay, node number 3, node number 4, node number 5. Okay, so in order for node number 1 to send the message to node number 3, they must send the data through the transmission channel, which is this ring topology, and they will go on to the following nodes. Okay, so the messages being sent will check whether this is the destination of the message. Then the node number 2 replies that this message is not belongs to him or her, right? Therefore, the message continues to the ring topology and move on to the following nodes, right? So the messages is meant to be sent from node 1 to node 3, right? So node 3 check the message and this is the correct address, and node 3 will accept that message. So it will stop here lah. So let's say node number 1 want to send a message to node number 5, they need to follow the circular change until finally receiving end. Okay, receive the receiver end. Okay, right? So there is the shape of star just now, and this is the shape of a ring. Okay. Okay, and the third I skip the mesh first. Okay, the third topology, which is the physical or logical arrangement, is the bus. Okay, okay, a bus is just like a bus lah. Okay, used to transport the data. Okay. Okay. So when you want to send a data from node 1, node 2, node 3 to node 4, okay, okay, we have a cable end at end side. Let's say you want to send a message from node 2 to node 4, so you send the data here, okay, and you wait the bus to come. So actually the bus will move through this communication channel from end to end. Okay. Okay, let's say, okay, PC number one and PC number two want to send the data. Okay, so let's say PC number two request for the bus first, and PC number one is the second one to send the data. Okay, right. So the bus will move to PC number two. Okay, and then PC number two will send the data, okay, to the bus. Okay, and PC number two want to send the message from PC2 to PC3. So this bus will move to PC number 3 and will empty the message and pass to PC number 3. Okay, so while the bus is sending the data from PC2 to PC3, PC1 cannot send data because the bus is not empty. Okay, so after the data have been sent to PC3, then only the bus is free, and they will go to the PC number one, and now PC number one able to send the data. Okay, in order to send the data to PC number 4. This is the concept of bus topology. Okay, and finally, excuse me, for mesh topology, right? Okay, the different, it looks like little bit similar with star. Okay, they have a connection or shape like a star, but they also have a line between one nodes to another. The red color, you can see the red color, right? I changed to red first. Okay, so this PC can send here 1, 2, 3, 4, and 5. Okay, right? So if star, they only have the star shape. Okay, but for mesh, they have additional cable, additional line. Okay, so they have additional line to connect every PC individually. One can connect direct from PC node 1 to node 2, can also connect from node 1 to node 3, can also connect from node 1 to node 5. Okay, so in other words, for mesh topology, it is more robust. Why? Because let's say the middle part, okay, let's say the the middle interconnection devices faulty, or any of the cable faulty, they still can send the data to another nodes. Why? Because they have so many wires. Okay, okay, let's say PC1 want to connect to PC3, so let's say this wire is faulty. Okay, they can still send the data, okay, using other cables. Or the other solution is, okay, let's say the middle communication interconnecting device is faulty. Okay, other communication still can take place, okay, by using different cables. Okay, so basically you can memorize the network topologies, okay, in a common sense approach lah. Okay, such as star in the form of star, ring in the form of circle like your ring, okay, right, and a bus system. Okay, in order to submit to send the data, they need to wait until the bus is empty. Okay, right, so this is network topologies. Okay, network topologies in detail. We have mesh, okay, ring, star, and so on, right? Okay, for mesh, each node has a dedicated point-to-point link to every other nodes. Cable needed is equivalent to n minus with n minus 1 divided by 2. Okay, n is actually a number of nodes or PC. Okay, let's say you are connecting 3 PC. Okay, so how many cable do you need? So you can use this formula lah. Okay, equivalent to, okay, n, okay, bracket n minus 1 divided by 2. So PC number of nodes is 3, right? So 3 minus with 1, do the bracket first, you get 2. Okay, okay, and then n times with 2, 3 times with 2 you get 6. 6 divided by 2 you will get 3. So you need 3 cables. Okay, and so on. Okay, okay, the advantages of mesh topology. Okay, each connection can carry its own data load, eliminating traffic problems. Okay, means that, like we have discussed just now, is if one cable problem, okay, they not affect the rest of the network. Okay, if one link become unusable, it does not incapacitate the entire system. A dedicated line guarantees security, easy fault identification, and fault isolation routable. Okay, means that if one cable problem, you can see that other PC can still send data. Then the cable which is infected, when they want to send the data and not able to send the data, we can easily find the solution, okay, or the problem cable. Okay, easy fault identification and fault isolation. Okay, even though mesh topology is the best topologies because they have so many fault tolerance solution, okay, they still have disadvantages. Okay, the first one is the amount of cabling and number of I/O ports required. Okay, let's say if you are connecting 3 PC, right? Okay, I want to give you an analogy lah. Okay, at hostel you can play FIFA or Pro Evolution Soccer with your friends, right? Okay, even without the switch, the 2 PC can be connected to each other. Okay, you just connect a cable from your PC to your friend's PC using a straight through cable. Okay, straight through cable, you connect the network cable and connect to the your friend's PC. Okay, that is one to one. Okay, only 2 PC only need 2 cables, right? Okay, what if you want to play games with 3 of you? Okay, 3 PCs, right? Okay, so one PC is connected, sorry, one NIC is used to connect the wire to the next PC, right? What about the third PC? They don't have uh, ports anymore, right? Therefore, you need to buy a new NIC card. Okay, so the new NIC card you can use to connect from your PC to the third PC. So you can see that we have two stack. Okay, stack of PC. So the disadvantages of a mesh topology, because it requires a lot of NIC and cabling, it is more expensive. Okay, for ring topology, each device is linked only to its neighbor. Okay, each device incorporate a repeater, easy to install and reconfigure. Okay, the disadvantages or disadvantage in unidirectional traffic, a break in the ring can disable the entire network. Okay, like the ring just now. Okay, we have 1 PC, okay, second PC and third PC, right? Okay, so you send the data from PC1 to PC2. Okay, okay, but in the case that backbone or network ring failure, okay, you are not able to send the data. Okay, so it means that a break in a ring can disable the entire network. Okay, because there is a failure in the ring. Okay. Okay, the question time. Draw a hybrid topology with a ring backbone and two bus network. Each network has 4 workstations. So I leave it to you all to figure out the answer. Even though I think the following slide will show the answer, please don't see the answer first. Try to do it by yourself and then compare with the correct answer with the answer scheme. Okay. Okay, the second question, draw a hybrid topology with the star backbone connecting two bus backbone. Each bus backbone have 4 workstation and 3 of them connect ring networks with 4 workstation. Okay, find out the solution and give me the answer with your submission later. Right. Okay, categories of network. Okay, categories of network determined by its size, ownership, distance covered, and physical architecture. Okay, okay, the categories of network you can memorize by using sorry, Malay name. LAN. Okay, Malay name LAN. Change the pen color. MAN and WAN. Okay, Azlan, Azman, and Azwan. Okay, right. So LAN is the smallest one. Okay, smallest network coverage. The bigger one is the MAN, and the biggest one is the WAN. LAN, MAN, and when it comes bigger, the name will change to WAN. Okay, LAN is a short form for local area network. Okay, normally we apply LAN in single building LAN or in single lab. Let's say you are using in datacom lab. Okay, or in your groups of 5 PC. Okay, so the groups of 5 PC is connected to the switch, right? So this one we call as LAN. Okay, so LAN can be the groups of your PCs in your group. Okay, and can be combined with the groups of PC in your friends group. Okay, 5 plus 5 and so on. Okay, and it becomes bigger. Okay, it will change to MAN or metropolitan area network. Okay, so for instance, a LAN of UTEM, okay, connecting with a LAN of College Yayasan Saat, right? The two LANs connected. This is the LAN of UTEM, for instance. Okay, connected with College Yayasan Saat LAN, UTEM LAN. Okay, and then connect with maybe a Srinagari LAN. Srinagari LAN. Okay, so all the LAN can be connected to each other. Okay, so when you connect all the LAN, okay, okay, now we call as one. Okay, so sorry, my mistake. Okay, supposed to be MAN. Okay, I'm sorry. Okay, if we connect bigger LAN, okay, so now it becomes MAN. So few LAN. Okay, we connect to a MAN. Okay, so this collection combination of few LAN we call as MAN. Alright. Okay, and the biggest category of network we call as WAN. WAN is a short form for wide area network, long distance transmission over large geographical areas, utilize public list or private communication in combination, and enterprise network in one owned by one company. Okay, let's say this is Malaysia. Okay, and UTM is located here in Malacca, right? Okay, and you need to browse Google, okay, in which the server in USA, right? Okay, so we have MAN here, which is MAN for Malacca. Okay, and maybe Google is in New York. MAN for New York. Okay, in order to connect between you and Google, okay, two or several one. Okay, so when it covers large geographical area of network, now we call as WAN or wide area network. So you can memorize by memorizing Malay name. Okay, LAN is the smallest network coverage, and then when it becomes bigger we call as MAN, and the biggest one is the WAN. LAN, MAN, and WAN. Okay, now we go a little bit faster. Type of network connection: connection to or more devices connected together through links. Link is a pathway or media. Okay, link can be a pathway or media in which the media can be subdivided into two, either wired or wireless. Wired or wireless lah, in which we will cover in the later section. Okay, the network connection can be physical or logical. Okay, right, for physical can be either point to point or multi-point. Okay, for logical it can be either peer-to-peer or client server. So in other words, physical means that something you can see and you can touch. Logical means that it is something that extracting. Okay, you have to apply some techniques, okay, or some application in order to perform the logical network connection, right? Okay, so this is a peer-to-peer connection, just like a match a connection model, which each party has the same number of capabilities. Each party has initiate a communication session. Let's say you are connecting between your phone to your friend's phone, or your PC with your friend's PC. So you need a cable if you are connecting using wired, or if you're using your phone, you can connect using wireless. Means that all the nodes is in the same capabilities. Okay, right? Okay, for logical connection, the second one is the client server. Okay, okay, the relationship between computer program, in which one program, the client makes a service request from another program, the server which fulfill the request. Let's say this is your PC. Okay, right? Okay, and you are thinking of accessing SMP to check your registration, right? Okay, okay, So you know that if you are accessing the SMP, you will type iutem.edu.my. So actually it will be like a client. So your PC will be a client. Okay. Okay, requesting SMP from server. So the middle part is the server lah. Okay. You are requesting what? You are requesting the services we call as SMP. Okay, from client to server. You request from the server and the server will grant the access to you. Okay, so now you can serve the SMP in order to check your registration. Okay, for physical connection, point to point means that in order for you to play FIFA and so on, you need to connect a wire. You can see the wire, right? So this is what we call as physical. Okay, dedicated link between your device and your friend's device. Okay, multi points, it is just like the switch or the access point that you are accessing the internet, right? Your phone can access the internet through the Wi-Fi, and your friend can also access the internet through the Wi-Fi. So you can see that it is a multi connection. So this is what we call as multi-point. Okay. The following part is the internet. What is internet? From the word inter and net. Okay. Inter means that like international, right? You cover a large geographical area. Like international. Okay. And net is from the word network. Okay, so internet is a worldwide, like I explained just now, international, publicly accessible series of interconnected computers networks that transmit data by packet switching using a standard we call as internet protocol, right? So previously you have learned about TCP/IP, right? OSI and TCP/IP, right? Okay, so this is what we call as internet protocol. In order to connect the nodes in the internet community, we use a protocol called internet protocol. It is a network of networks that consists of millions of wide and local area network, such as domestic, academics, okay, World Wide Web, and so on. Okay, in order to connect to internet, let's say at home, what you need to do? Firstly, you need to subscribe to Unify, right? Or Maxis broadband. Okay, so all that Unify, TM, Maxis, and Cellcom, all the companies we call as Internet Service Provider or ISP. Okay, and ISP can be subdivided into local internet ISP, regional ISP, national service providers, and international service provider. Right, so this is the diagram of ISP for local and international ISP. Okay, extranet. What is extranet? Okay, it comes from two words, extra and net. Okay, extranet is an intranet for outside organization using same internet technology, inter-organization information system, enable outsiders to work together with the company's employees, open to selected suppliers, customers, and other business partners. Okay, so supposedly the notes explain about intranet first. Okay, intranet is something like SMP, in which you can only access in UTEM, but you cannot access outside from UTEM. Okay, so application that you can only access in UTEM we call as intranet. Extranet, on the other hand, okay, because normally intranet allow only access to people within the organization. Okay, but UTEM still need to collaborate or need to communicate with their vendors. vendors that sell that want to sell PCs, okay, vehicles, and so on, right? So of course, the outside parties or outside companies not able to connect to the intranet. So in order to be able to connect, okay, you then have to allow the concept we call extranet. Only specific organization or company or vendors can connect to intranet. We call as extranet. Okay, this is example of extranet dealers such as selling PCs and so on. Right. So this is the bigger picture: intranet, extranet, and internet. Intranet is only for corporate members or within the organization. Okay, extranet, um, the clients or the vendors still can access the intranet, but only for specified clients. Internet is a website in which can be sorry, can be accessed by everybody in the whole world. Okay, that's all for the first part. Thank you.